Hi everybody, my name's Connor McDonald. Welcome to another one of the APAC OUC webinars put on by Francisco and his fellow members, of which he is predominantly the guy that organises the whole lot, so thanks very much to Francisco. It's 3 p.m. in the afternoon in Perth. It's a glorious day in Perth, and given that it's a Friday afternoon, hopefully you've got your favourite beverage in hand. I've been very controlled and not cracked open a beer for this webinar, but I'll possibly crack one afterwards. I come from Perth in Western Australia, so anyone that's joining us from overseas, that's where the red arrow is on the map. I generally try to travel as much as I can through the United States and Asia if I can, but I'm based here in Perth in Western Australia. Before we get going, obviously there's a little bit of marketing stuff that I have to cover, as I always do. Most importantly, please reach out to me on Twitter or via my blog. That's at Connor_MC_D on Twitter or Connor-McDonald.com. I would love to see you reach out and get in touch. There's a lot of like-minded people out there in the Oracle community just itching to actually talk technology with you. That's one of the reasons I'm motivated to do these webinars. I also host a YouTube channel, Connor McDonald Oracle from youtube.com. I realized recently that when I had a problem with my sink at home and the drain got plugged or blocked up, the first thing I did was search on YouTube for a how-to video. So I figured this is the obvious place that people are now looking for good information on how to do things. The other thing I spend most of my day doing is looking after, with two other people, the asktom.oracle.com website. Originally named after Tom Kite, who set up the site. Now it's Ask the Oracle Masters. Myself, Chris Saxon, and Maria Colgan look after the site, taking your questions and hopefully helping you be more productive as a developer or database administrator. After this session, I'll be putting the slides on the resources tab such that you can download the slides or watch the YouTube replay. I'm part of a team inside Oracle called the Developer Advocates team. There's 5 of us currently, led by Stephen Feuerstein, a name you probably know from Pure SQL background. Our job is pretty simple. It's to make you more successful with Oracle. That's our job. That's all we do. We're not trying to sell you products. And obviously, it's not just totally philanthropic. We know that if you're more successful and more productive with Oracle and your applications are successful, then what's going to happen is you'll probably end up spending more money on Oracle products. But hopefully, it's a win-win for all of us. We want to make you more successful with Oracle, therefore, everyone wins. All the demos you'll see today, and there'll be screenshots of demos simply because of the webinar software. It probably doesn't lend itself on a global scale to running real-time demos. We're done on 12c release 2. So I'd thoroughly encourage you to get out there and be on 12c release 2. It's available now. So the topic for the day, Schema-less, Schema-now, Schema-later. A bit of a play on words in the concept of a lot of people now are very focused on doing minimal design work, minimal activities, and just jumping into coding versus other people who are much more interested in a strong design process up front. I view it more on this way, developers versus DBAs. It's probably the same title, really. That is, developers want to jump in and start coding, whereas DBAs are renowned for perhaps being often seen as the stumbling block or the blocking point in that process. The question is, can we do a better job? A quick thing on the safe harbor statement. You've probably seen it in every Oracle talk. We'll move on from that. So what I really want to talk about in this seminar, or this 1 hour we've got, is trying to bridge the enormous chasm that tends to exist in organizations between developers and DBAs. They often almost come to blows. There's this sort of unseen rule that they will never interact with each other. And part of it, I think, is due to this. When we think of DBAs, as a developer, if you ask them what they think of a DBA, they'll often say, well, they're someone who probably only remembers the original version of Star Trek. They probably have some interesting choices in footwear. They might wear an old bowler cap, or they're generally seen as sort of the older people in the organization. And, we generally think of them from a developer's perspective as perhaps being uncool or problematic, or people that block our way in the organization. Ask the DBAs what they think of developers, and you get just as a similar visceral response. They say they're sort of too cool for school, they're young and haven't got enough experience, don't know how to wear their jeans properly, probably like Justin Bieber, and spend their days drinking too much Red Bull and not putting enough thought into doing applications. So you can see that these cliches or these stereotypes generally create a fair bit of angst between the two groups. And that's a really sad thing, that this webinar today is trying to address that issue. The DBAs have these attributes which would all be seen as positives from any manager. They're generally cautious people. They don't want to basically create problems inside their databases. Hence, they're risk averse. Their focus is on the fact that data has a longevity. There's a lot of importance to that data. It's going to be kept for a long time. It needs to be securely backed up and looked after, and hence security. Ask a developer about those 4 attributes, and sometimes they say, yeah, well, that's all the stuff that just slows us down. So they often see these as negative attributes. Similarly, ask the developers about what attributes make them positive, and the fact that we're fast, we're agile, we get stuff done, we're productive, we deliver stuff on time. Our customers ask and we deliver as fast as possible. They see all these things as positive attributes, whereas often the DBA says, well, that just means we're going to get hacked. They haven't put enough thought into things like security and like that. The reality is both of them are right? Both of these things are needed in the modern world. We need good security, good understanding of backup and data longevity, but we also need to understand the needs of the modern customer. That is, we need to deliver fast, get things out and running fast. The question is, how do we stop these two groups just confronting each other and creating problems and having all sorts of arguments and having dramas? That's what we need to try work around. So what we're going to do today is do a little bit of a role play. I'm going to effectively wear 2 hats through this session, one being of the developer and one being of the DBA. And we're going to go through what I would say is a typical starting point where developers and DBAs are at loggerheads, but we're going to see if we can get them to come closer together as we work through some of the features in the Oracle database to actually maybe help DBAs help developers and also help developers help DBAs. Hopefully we'll end up with what I call a better world. That's our plan. So here are our two participants. We have our developer as indicated by the t-shirt on the left and our DBA as indicated by the slightly older t-shirt on the right. And let's begin our role play. Developer says, as part of our new campaign, we're going to record all sales transactions. DBA says, that's fine. Let's see your requirements documents and we'll design a good data model, create some tables, and obviously get you involved in getting up and running. Developers, we don't know any requirements yet. We've just been told by the customer we need to start recording these transactions and we need to start doing it this week. And the DBA says, well, we can't, that just doesn't fly. We can't start anything without a data model. And obviously in the modern world, the developer may then say, well, I've got these, we've had our first sprint and we've had our first meetings and we've thrown some cards together and this is pretty much what we've got. And the DBA says, well, that's not a data model, buddy. No way. That's nowhere near sufficient for me to go design you a database. The developer rightfully responds, but we're agile. We don't know the data model yet, but we just need to start delivering. And of course, the DBA puts that first roadblock up. You're not so agile anymore because you're not getting past me. So what happens in these scenarios? The reality is we can't sit there in a stalled situation. Developers will find a way to simply move forward. So you'll see things like this. The developer will now start sending an email to, for example, the CIO. Here's our status report. Yep, we've commenced work on the sales recording application. We're going to use MongoDB. And why would they choose to do that? Well, it's probably obvious. They tried to approach the DBA, tried to get something up and running, and couldn't. So developers don't really have a choice. They'll simply shift elsewhere to do something to work, see what they can do. Of course, the DBA will absolutely lose his mind when he sees this. And he's right as well. He has the same issues. The DBA is going to say, well, no way can you just jump out and use a brand new technology. How are we going to back it up? How are we going to secure it? How are we going to monitor it? What OS does it run on? It's a big challenge to a DBA to actually adopt a new technology. And the key thing there is the developer might be thinking, well, that's not my problem, but it may well be his problem because you've got to be able to back this data up. What's the likely result of that thing? Well, there's 2 likely outcomes in 3 months of that kind of argumentative process going on. This is Possible outcome number one. Developer says, yep, we went to Mongo, we finished 3 months ago, but we still haven't deployed to production because we're waiting on the DBA. And what's the general consensus among the developers then? Well, we think our DBAs suck because they become a roadblock. That's not a place we want to be, but it's common nowadays. The other second likely outcome is something like this. The DBA absolutely laughing because guess what? Because they raced out, the developers raced out and went for Mongo and got something deployed. Well, new technology didn't really perhaps understand all the nuts and bolts of it, neither did the DBAs who were tasked with looking after it, and therefore that organization just becomes the next on the list of organizations that got hacked because they didn't really understand how to manage their MongoDB. This is not a criticism of MongoDB in itself. It's the fact that there's been many examples where people have simply raced out, grabbed Mongo, configured it with all the defaults, including exposing the database with all the default passwords on the internet, and then being taken to town. So the two likely outcomes are both bad. Either you're going to get hacked or the developer's stuck on a roadblock. And of course, the DBAs then say, well, developers suck because we got hacked. Both are right. We don't want to end up with slow deployment, which hurts the developers, but we don't want to end up with unsecure, untested, unknown technologies, which hurts the DBAs. We've got to find a common ground. Quick turnaround is a reality nowadays. The DBAs need to face that fact. Quick turnaround in application is a reality. Unknown data models, as a result, is a reality. We don't have the time nowadays in the modern world to simply spend months and months and months doing database design. We still need some, but we do have unknown data model requirements. But by the same token, recovering your data is a reality and has always been. We can't just leap out and use brand new technologies simply because we want to be fast and loose, because there's a good chance we'll lose it if we can't back it up. And obviously keeping that data secure is probably the most important thing in the modern world. We've seen so many examples of people being hacked and losing not just their data, but sometimes their entire business. So let's look at that better way. Let's have the DBAs and developers working together. This is one of my favorite quotes. Developers spend their time thinking, oh man, I have to put up with the DBAs. DBAs think, man, I have to put up with the developers. Maybe you're just even. Maybe if you work together, things will work out nicely for you. So let's revisit that same example. Developer says, we need schema-less data recording. Can you set up MongoDB for us? DBA, without just going, no way, can actually explain why that could be an issue in the organization. A new technology means lots of lead time. We've got to learn security procedures, backup. Why would you want MongoDB? Is it just because you want a document store? Developer says, yep, the data model is unknown and likely to evolve as we start building and understanding the products. Well, rather than using a new technology, why not use a technology that you've already got on site? Why not use Oracle for that? And of course, your average developer nowadays might go, using Oracle, a relational database as a document store. That sounds extremely strange, but it's true. Let's look at an example. Once you get to Oracle 12c, which hopefully most of you are all moving to, Oracle has some excellent facilities to use it purely as a document store. Let's start with a simple example. I'm going to create a table called orders. It's got an order details column, and it's just a blob, just a binary lob. One of the cool things you can do in Oracle 12 is say the contents of that blob, and it can be a club as well or a varchar, you can take your pick, but we're using a blob for this example. The contents of that blob must be a JSON document, a valid JSON document. That's very useful when it comes to loading JSON data structures into the database. It can be blob, clob, or varchar too, as I said. We're going to use blob. All the normal goodies apply. It's a table inside Oracle. So you can partition that table should you want to. You have indexing on that table. You could have encryption on that table. You could have compression. All the normal good things apply that you normally get in an Oracle database, just equally apply to having the database using as a document store. You can even use rack if you want, if you use clustering. So now you can scale horizontally as well. And finally, in the modern world with modern cores and lots of cores on servers, you can do operations in parallel. All the normal stuff applies. And more importantly, If you want to replicate that globally, you could use something like Golden Gate or Streams or any of the replication technologies that also come with Oracle, all out of the box without learning new technology. The developer says, that sounds pretty dodgy to me. Yeah, I'd need to see a bit of a proof of that. Well, let's explore that. Now, a quick word. As I said at the start of this session, the demos here are going to be screen dumps of the demos. We could run them live, and hopefully if you ever get to come to one of this talk when I do it live, you'll see we'll actually run these demos for real on the database, but we'll just do screen dumps due to the webinar latency, and also so you can watch this nicely on YouTube at a later date. So here's our Java program. It's just a stock standard, very, very simple Java program. The class is called load order in JSON. And you can see it in red. I'm just doing a stock standard normal JDBC connection to the database. Nice and simple. And here is a stock standard prepared statement. Insert into the orders table values. I'm going to take that string, order details as a binary variable. I'm going to cast it to a raw because I'm storing this as a blob. I'm using a document store in the ultimate sense of the word. It's going to be binary data that we can't even view in the database. Yet we're going to have all this goodies and such involved with it. There's the set string command, and you can see, even though it's hard with Java because we have to escape all the double quotes, it is effectively a JSON document. This is someone's order. You can see there's the date of the order, the loyalty card number, the location that it was placed in, etc. A piece of JSON inserted into a blog column. I compile that program, I run it, and as you expect, it's just a nice, simple insert statement. Fairly simple. If I jump into SQL+, and do a select star from the orders table, just to prove the point, there's no magic going on here. That is just a piece of binary data. Just like a lot of the other document store databases out there, each use their own proprietary format. There is stock standard hex binary data stuffed into a blob column. Yet, because we have that check constraint, we know that the string data in there is indeed valid JSON. So you can simply use a straight out insert statement to insert your JSON stores as strings or as binaries we've done here. So now we have a happy developer, right? He didn't have to go out and invest and install and configure and learn a brand new technology. We've given him a facility, in this case with Java, or generally any 3GL, to simply store data just like a document store. Developers, Dave says, well, actually it's more than that because it's existing technology on site. Guess what the DBA has to do in terms of understanding the backup process? Nothing. His existing backups are going to back that stuff up. His existing security model is going to work as well. Just like all their existing Oracle systems that might be just relational databases, this works in the same way. You've actually saved an enormous amount of learning and organizational effort in your IT department to actually get this document store up and running. Happy developer now. Rather than having to learn a whole bunch of MongoDB APIs or some other new technology, he's a week ahead of schedule because he's just good to go. He's got a document store at the ready. And of course, the DBA is probably not going to be convinced. He's going to say, well, that's great. I've given you a document store, but why not model the data? What's the benefit of a document store? And this is part of that to and fro that we'd like to see now in organizations where developers can actually give DBA some insight as to why they adopt the things they do. And here's an example. This is why JSON is such a cool data structure to have. As DBAs, we often think, oh, why don't they model it properly? And why don't they do some transposition before they get it into the database? But the reality is, if a developer's got some JSON just like that, just stored in a variable, to actually convert that into a nice JavaScript object, it's a one-liner. JSON parse it, and now he has an object structure that pretty much marries that data. In terms of coding convenience and simplicity and facilities for the developer, that is pretty awesome. And as a DBA, hopefully any sensible DBA would say, they'd say that's a pretty cool thing to see. So our developers now a week ahead of schedule. Life's looking good simply because the two parties actually colluded with each other and collaborated a bit. But then our developer sends a status report. Our initial game looks like it might be chewed up. To load data into Oracle just as a document store, well, we need to have the Oracle client installed and configure that. Developer might not have done that because they're JavaScript developers. We also need to learn how JDBC works and handles the blob things, because if we want to fetch the data back, we have to write queries to actually get the data back. We reckon that's going to take us 7 days to work out, and there goes our week ahead of schedule. We're now back to status before. Luckily, though, our developer CC'd the DBA because he had a pretty good collaboration with the DBA a while ago. So the DBA says, I saw the status report. What's the drama? The developer says, well, we thought a document model would actually make our code easier. But the reality is we have to write all this JDBC code to write. From the Java demo you showed me, it's not a lot, but it's all brand new, so we have to learn it, we have to debug it, and obviously we're thinking, well, we should have just gone for Mongo now in the first place if we have to learn all this new stuff. Well, the DBA might say this. He might say, well, that's databases for you. You need lots of coding. That's just tough. That's, again, not something we want to see from either party here. We don't want to have that lack of collaboration. The developer might say, well, can't we just do REST calls? I mean, most non-database applications, you can simply just call APIs through REST to get whatever you want done. Whether it's calling a web service or calling anything else. If I want to get stuff done, I just call a REST call. And the DBA might go, well, nah, databases don't work like that. Sorry, you can't have that. When someone says things don't work like that, what it often means is, I don't really know what terminology you're referring to, and I don't want to lose face, so I don't want to accept any change. This is a tough challenge for both of us as DBAs and developers to accept that when we encounter new technologies and new terminologies and new things, that maybe we actually just need to do a bit of study rather than actually just outright say no. So the developer explains, what is REST? Representational state transfer. It pretty much is the language of the internet nowadays. Really, it's effectively a client server, and not in the legacy form of client server, but the fact of a browser making a call to an app server or app server making other calls to other app servers. It's a simple request response model that can be done over HTTP. The cool thing is, generally the model in which we actually pass data is JSON, which JavaScript developers are familiar with. It's a stateless operation and can be done consistently across all platforms using a URI syntax. And it's a very simple model. It simply gets puts, very similar to what you do with HTTP requests. So you think about something like this, a request like myserver.com/orders/100234. It looks just like a normal web URL, but it might actually be a REST call. That is, go to this particular server, look for the REST object called orders, and do something with order number 100234. It might be, get me the orders for customer 100234, or it might be, here is a new order for 100223. The cool thing is, it is simply a nice simple call through HTTP, which most people are familiar with, using JSON, which developers are very familiar with, using familiar get, put, post commands, etc. It's a very simple and easy to digest routine, but obviously not something we generally see in the database world. But because the developer took the time to explain it to the DBA said, okay, I'll go do a bit of reading, and he'll probably discover that you can allow access to the database via REST. And the developer might go, oh God, here we go. I have to wait for the DBA again. I'm back to that same old problem where I want to get something done and I have to wait for the DBA. This is going to take me months. Okay, then how long? How long is it going to take? And the DBA might surprise him. He might say, grab me a six-pack and I'll have a REST layer for you ready in 30 minutes. Of course, at which point the developer's first thought is, wow, a DBA that drinks. That's a bit strange, but let us move on. Our developer might be pretty skeptical of that. How can we build an entire REST interface to our database just in 30 minutes? Well, we have a facility that does that in the Oracle database called ORDS, Oracle REST Data Services, and it is incredibly easy. If I was running ORDS, which is effectively the way you run an Apex listener nowadays, it's a facility that actually provides REST services out of the database. I've got a screen up there of how you run it literally on a PC, and it really is that simple. This isn't what you use in the production world. In the production world, you'd obviously install this as part of a WebLogic component, but on your PC, you can run ORDS simply by firing up Java and running the ORDS jar class in standalone mode. That gives you both Apex, but the ability to have ORDS as well. How do I turn on ORDS? as a DBA, it's easy. It's familiar commands because I can do it in PL SQL. I can also do it in SQL Developer as well using a GUI. In this case, I'm turning on the schema, turning on REST services for the schema called Scott. Nice and simple. Or I can do, for example, enable an object, in this case, the orders table, using an alias called REST orders. That'll be part of our HTTP URL that lets us access the orders table. So since I've turned on the entire schema called Scott, I can do simple things like this. I've connected to my local host, which is where I'm listening on my database. I have ords/Scott the schema/emp. And just by doing that simple URL syntax, it gives me a JSON structure of all the data inside the emp table. You can see the familiar emp no 7369 employee name equals Smith from the scott.emp table. We get one JSON snippet for each row in the database, and you can see there's actually even links inside there to actually drill down to each individual employee. So for example, if I click on 7369, I actually get the details for just that employee, like a drill down information. It's another REST call back to the database. But literally a couple of PL SQL APIs, and I can enable REST structures straight out of the database through ORDS to calling clients. So now let's revisit our Java program that a developer has to write. It's a Java program now, and you can see there's actually no longer any connection to the database. There's no calls to JDBC stuff at all. In fact, he's doing things that, or she would be doing things that are very familiar to them as an application developer already. They're simply doing HTTP calls, in this case to localhost 8080 ords Scott REST orders, that alias I gave it before. And I pass in the JSON, whatever that JSON may need to be, and I simply call a post call. That's how I can now insert a row into the orders table without any knowledge of the database at all. As long as I have the JSON and I can call HTTP using post, the job is done. That makes for a very happy developer. Cool. All I need now is a simple post call. Anywhere you can access HTTP and have REST services exposed, you can do it. The cool thing is, the same thing I've done there on my local machine, I could do on a cloud service. And in fact, if you grab one of the Oracle Cloud facilities, one of the things in the console is, do you want to turn on REST for your cloud database? It literally is just clicking on a few buttons here and there. So I can simply say, yep, I'm going to have a service called, for example, JSON REST. There's the URI prefix. It's me coffee shop. That's what will appear in my URL. And then I simply add a template for the rest of the URL. And obviously in a real world, we can do things like authentication and security to make sure only certain people can access it under certain circumstances. But literally it can all done with point and click if you're using one of the Oracle Cloud databases. You can even access things like PL SQL in there if you want to. We can actually access things along the lines of anonymous blocks, once again with a post method. I'm looking at my client service. Oh, it has caught up. So here's an example where I want to do a post, and rather than doing just a straight insert, I could actually, for example, do an anonymous block. In this case, it's a simple insert anyway, but I could do all sorts of interesting things in there using a PL SQL block. Once again, all just point and click, and it's ready to go. So now we have a happy developer. We have a document store in the database. Easy REST access, therefore no database code to write. Our DBA is going to go, yeah, isn't that cool? And he's probably going to sigh to himself because it's a sad thing when a developer is very, very happy when they don't have to go near the database. He's going to be probably a little bit distressed by that, but it is perhaps a reality now that developers are separating themselves from the nuts and bolts of the database and accessing them via REST. It's a fact of life. A few days later, here's our developer doing his status report again. It looks like our initial game might be chewed up. We're going to need to build a parser for our JSON documents to extract the fields from the documents. We're also seeing some network issues in our testing. Now that's a bit strange, but luckily the DBA has been CC'd. DBA says, I saw the report. What's the drama now? And the developer says, well, as I showed you before, parsing a JSON data structure into an object is easy. It's great for that. But as we've been building our application, as the requirements have been evolving, we have to actually start producing reports, which means parsing all those fields out and presenting them in a report format. So we're building a parser to actually convert those JSON documents and objects into nice, simple to digest reports for the customer. The problem there is, of course, is to parse that JSON structure, I need to drag it across the network to my app server, which of course are those big documents we're storing as blobs, and that's slowing down the whole network. DBA can help out here. He says the database can do that for you, just with simple SQL. And that is one of the great things of storing your JSON documents, even as a document stored inside an Oracle database. We have access to a SQL language now to actually extract the bits and pieces we need. Now, the developer might be a bit dubious to that because, if they're a JSON programmer or a JavaScript programmer, the word SQL probably strikes fear into their hearts. But let's have a look. In Oracle 12c, you do have native JSON SQL support using the familiar dot notation that anyone that's used SQL before would be familiar with when they've done with, for example, dealing with objects. So here's my orders table, which, as you can see, just has an orders detail column, and it's just a blob. And we know that inside it are JSON fragments that look something like this. How do we access those particular attributes inside the JSON structure? Well, we can do it with simple SQL. And as the name suggests, the dot notation, it simply is just walking down the JSON structure. I'm going from orders with the alias of O. I'm going into the order details column. Inside that column, which is our blob, I'm going to the location entry inside our JSON structure, and then the city scalar within that, doing a select statement, and you can see I actually get the rows back. I've navigated my way down the JSON hierarchy and got the city information. It's that easy to do with SQL. Now that's a happy developer, because now I don't need to bring the whole JSON blob across the network. I can just access the fields I have in SQL and drag them across the network. Much, much more efficient and nice and easy to code that stuff up. The other thing the DBA can offer is say, well, don't forget, because it's just stock standard Oracle SQLnet, we can actually compress that data across the network. So even if when we're pinging just the data we need across the network, if that still causes network problems, we can actually compress it as well. Once again, re-enabling the use of existing technology. Cool, says the developer, we can ditch building a parse now and just use SQL queries. Now, that in itself is an exciting moment for a developer to be excited about writing SQL. After which, a developer can now send a status report. They've solved a whole lot of hassles because they didn't have to write a parser, didn't have to use a new technology. They're done. They're very excited. They're very impressed with the fact that they've managed to get some gains by using existing technology. Ready for liftoff, as they say. We now have a system which is agile, so they've built enough to be production ready. They haven't had to use a lot of database code. They've used some benefits of database code, a little bit of SQL here and there, and they've managed to rapidly deploy a document store. So they've been agile, quick to deliver, plus all the benefits that DBAs need, longevity, security, backup, etc. A few days later, DBA makes an inquiry. How's it all going? Well, it's been a huge success as a developer, and that is the joy of good collaboration between DBAs and developers. It's a massive success. And of course, what happens when any system is a success, you want to integrate it with other systems in your organization. Because when you have successful data, people want access to that data. So the developer says, now we're integrating the data with the CRM system. What we've done is we've started a brand new project to match all the sales data that we're capturing in our orders table to the customers in the CRM system. And the DBA will say, a project? Seems a bit odd because the CRM system is just running on Oracle as well. And in fact, it's even on the same box. In fact, it might even be in the same database. Well, that's true. But of course, the CRM is a relational system, one of those old style legacy things that developers don't like. Our new system has just got documents as blobs. Yes, they're JSON, but obviously you can't just match a blob to relational data. So we're writing Java classes to match all that data up together. And here's one of the cool things, once again, because you use an existing technology. You don't have to, says the DBA, integrate it at the application level, because we might be able to integrate that data at the database level for you. The developer says, well, how? You don't know what's actually in our blobs because the JSON obviously can change from row to row. In fact, the developer makes a bit of an admission here, says, we don't even know what's in our blobs, because that's one of both the benefits and the worries of something like an agile system, in the sense that as an application's data evolves, you might have different types of JSON as that data evolves with it. Right? That's one of the really cool things about a really flexible data model. You can evolve very rapidly, but obviously you have to pay a penalty for that later on when you're actually trying to digest that data. Believe it or not, the DBA isn't panicked by this. The DBA is now starting to come on board with the concept of fluid database design. He'll think, well, guess what? Even like that, even with totally fluid JSON structures, the database can probably do some of that for us. Developers not convinced. But in 12C, we have a thing called the JSON data guide. And as the name suggests, it's a guide to what data is inside your JSON structures. What happens is, it's a way of doing metadata discovery inside your JSON structures. What happens is we actually run the JSON data guide against your JSON, and it produces a report of what attributes it found. What it can then do is say, well, based on the kind of information you found in the JSON, we can add virtual columns and create relational views on top of that JSON document to expose the data in a relational fashion. That is very useful when it comes to things like report generation, or in this case, integration with other systems. So to give an example of how the JSON guide might work, there's our order details column from our orders table. I can apply the JSON data guide to that. And what it does is it returns, like chicken and egg enough, a JSON structure, but that JSON structure is a listing of all the attributes and the possible data types for those attributes it found across all the different JSON documents in that column. So you can see there, I had a path to date, I had a path to order, I had a path to location, inside location, I had city, and so forth. So effectively, it's a way of getting an understanding of what the hierarchies are in your JSON structures. Once I've done that, I can use standard SQL queries. So here's an example now of how I could, for example, match our orders blob document data store to our customers table, which let's assume is in our CRM system. I can use our dot notation we saw previously, or o.orderdetails.loyalty card number and orderdetails.location.city, and make standard joins to the customers table, which is a relational system. I'm blurring the distinction between document data store and relational structures, which is awesome when it comes to integrating the two. Developer says, hold on a second. Let's think back to a couple of weeks ago where I wanted to get away from database access using REST. I might know a little bit of SQL, but starting getting in all these joins and all this kind of stuff and dot notation, that's getting pretty much outside the league of us as JavaScript developers. And once again, this is where collaboration can help. Rather than a DBA going, tough cookies, go and learn SQL, buddy. Well, the DBA can actually help out here. He can actually say, well, we'll abstract that complexity away in a view. Now, that might be the DBA, it might be your senior database developer, doesn't really matter. But that way we can expose very simple queries to the actual non-database fluent developers. Our JavaScript developer might think that's a bit dubious, but it's pretty simple. As we know, we simply can do create or replace view, top 10 customers on that same structure. Now it's just a simple query to the top 10 customers view rather than having to understand all the intricacies of SQL. We'd like all our developers to be SQL fluent. There's no guarantee that's going to be the place in your workplace. Developer says, thanks for that. That's cool. I've got this great view now called top 10 customers, and I can just do select star from top 10 customers. But I don't think that's going to work for us, because next week, this sales system has been so popular, we're going to have 2 million records. I don't really want to be querying 2 million records all the time. As a DBA, we're generally used to obviously much data volume, so we generally don't worry about it. Developers often think that 2 million or something like that is a big deal for databases. So they'll often go build their own systems to try actually handle this kind of stuff. And this developer has said, look, there's only one database server. we can have an infinite number of app servers. So we're going to deploy parallel app servers to handle that volume. Then we'll drag all that data down locally and do the joins and matches there. The DBA, once again, keep that collaboration hat in mind rather than being aggressive, says, well, that's going to cause network dramas. How about, rather than having to churn through those 2 million rows, we could actually have the results, the top 10 customers' results, already prepared for you in advance. The developer says, the answer prepared already. Like, how is that possible? The DBA says, well, we can store summarized data based on detail. Why can we do this? Because we're using existing technology inside the Oracle database. The developer's still not convinced. He's going, yeah, no thanks, because then if you give me a new table of all the summarized data, then I have to change all the code I've written to use that new table. And the DBA might say, well, if I said you don't have to change a single line of code. The developer says, that sounds a bit dubious to me, but it's true. This is a concept called materialized views that we often think of just for warehouses, but they're not just for warehouses. Because one of the things that came in materialized views in several releases of Oracle ago is the ability to refresh them at far more frequent intervals. You can actually refresh them in what we call fast mode, which is just picking up deltas. You can even refresh them on commit time. Every time a transaction commits, if the frequency is not too high, we can refresh a materialized view then. Or in 12.2, there's some new facilities where we don't actually need to refresh a materialized view, but we can still have the data inside it being fresh by using the on-query refresh view. But let's look at an example here of our top 10 customers. I'm doing enable query rewrite, that's the keyword here, and there's our standard view clause we had before, the join between orders and customers. Now when our developer runs that previous query, whether it's a view or whether it's the SQL directly as we see there, one of the cool things in materialized views is we can actually do this. The database will automatically and transparently rewrite the query to access our materialized view without having to change the base SQL. So he gets the performance benefit without having to go back and change all that code. When we run it, you can see it's, in this case, takes just a second, even though it's 2 million rows. That is an excited developer. This is awesome. All our reports now are nearly instantaneous. That's fantastic. A few weeks later, our developer returns and says, I'm so happy with those materialized views. I'd like another 77 of them. The DBA says, well, why do you need 77 more materialized views? And the developer says, well, it's just been success upon success. We had an orders, a sales system, which is just fantastic because it was fluid and agile. Then we integrate with the CRM system, and with our materialized views, those queries are nice and fast as well, the existing ones in the application. Everything is so well received now that marketing has said we want to access all the data in the orders and CRM system together like our canned reports do, but we want ad hoc SQL. So I'm going to need 77 materialized views to handle that kind of stuff. DBA says, well, that's probably not going to work because ad hoc SQL means they can run any query they like. And obviously we can't have a materialized view for every single permutation. Well, that's a problem, the developer says. I'm going to get fired because I just requested access for everyone to get our order history table. And because I'd seen this materialized view stuff, which was so cool, I promised everyone they'd be super fast results. Are you telling me I can't have it? The DBA says, well, actually, it's possible that you might be able to actually use a thing called the in-memory column store. But it's a database, the developer says. Our stuff's already in RAM. DBA says, yes, it's in RAM because that's how database work. But that's a thing called the buffer cache. Now, that's awesome for storing rows of data. When you go get a particular order or a particular sale record or a particular customer, the buffer cache is fantastic for that. But of course, your marketing people don't want just a couple of rows. Ad hoc query normally means I want to get all the data for this year, the last 10 months. I want to sum up all the sales for the last financial year. It's generally scanning huge amounts of data. To do that, we need a columnar format, a different kind of format that actually is good for accessing lots of rows at a time. At which point the developer says, I have no idea what you're talking about. Much in the same way our DBA was lost when the developers talked about REST. This is the importance of collaboration. It sounds like rubbish. But in 12c, we have a thing called the in-memory option. It is a facility of taking your typical row-level operations that work on the buffer cache and taking that same data and storing it in a column format in memory as well, but it's a column format and also compressed. So for doing analytic large-scale operations, we can access the column-based memory, and for doing our typical row-level operations, we can access the row-based information. We can actually serve both parties here using different forms of in-memory. So we have to use obviously a bit more RAM on our server because we actually have the data replicated now across two different formats, but that's much, much better than actually having to copy the entire database to a new technology or a new structure. And obviously that normally involves latency as well. Even when it's JSON document stores, you can store this stuff in a column format in memory. What we can do is we can actually take our JSON attribute fragments, expose them as virtual columns in our tables, and now that they're columns, we can put those columns into the in-memory store and therefore get rapidly super fast analytic queries on it. So here's an example of what we might choose to do. I'm going to add 4 new columns to our order history table, one called city, one called state, one called sales amount, one called loyalty card number. And we're going to use the JSON value function to extract the particular JSON fragments we need to expose them as columns. Now I can take our tables, the customers table from the CRM system and our orders history table from our new sales system, put those tables into in-memory. Now, by default in 12.2, that will just put the normal columns into the in-memory store. So if I want to actually put those virtual columns in, I might need to do a syntax like this, say, put the city, state, loyalty card number, and sales amount explicitly into the in-memory store. The reason I'm doing that is by default, the parameter in-memory virtual columns is set to manual. It's my job to actually force them in there. If I set that to automatic, then it'll actually automatically put virtual columns in the in-memory store as well. Now to prime our in-memory store, I'll do a full scan of the customers table, a full scan of the orders history table. Once that's done, background processes will race off and actually start compressing that data and putting it into a columnar format. You can see, you can actually monitor that how it happens using $IM segments. You can see that the customers table was completed because it was fairly small. The orders history table has started, but there's still some work to do. If I leave it a little bit longer, you can see the orders history table is now also in the in-memory store. So now those tables both have a row-based representation in memory and they have a column-based representation in memory. Now, when I run those queries, those expensive queries against the ordered history table, even without a materialized view, the execution plan shows us it's actually accessing the in-memory column store for those tables, making those queries incredibly quick for analytic style operations. In fact, we can see there that when I ran that query, we actually only did 19 consistent gets. We actually did almost no physical I/O to actually satisfy that query of 2 million order history records. It all came out of the in-memory store. Our developer says, that is super cool. Now, how do I keep all that column stuff in sync with the real data? And the best thing about the in-memory store is it's all automatic. There's actually no additional work for you to do as a DBA or a developer. Once you put something in the in-memory store, besides monitoring the memory consumption, effectively it's done for you. The next day, our developer says, look, you're going to be a bit upset about this. And the DBA says, why? What's happened? What's gone wrong? Well, it's almost too good for the marketing people. It's too easy. They can run all these reports with ease. They all come back super fast. No matter what permutation they come with, the reports are running beautifully. Isn't that a good thing? Says the DBA. Isn't that, we're trying to have satisfied customers here. Well, here's the problem. It's like giving someone enough rope to hang themselves. They're running any SQL they want, getting all the data results they were always desperate to get and couldn't get in the past. And of course, now what are they doing? As every person does in an organization when they have easy access to data, they start emailing it all over the place. And we've got confidential data in there. We've got customer names and credit card numbers and stuff like that, and email addresses. You can't be emailing that around. That's insecure. Oh dear, says the DBA, that's a bit of a problem. The developer says, look, it's great, but we need to sort this out. And this is a security hole. And this is the great thing about collaboration again. We now have a developer who's mindful of security. All this collaboration between the two parties, DBAs and developers, is teaching one another about the importance of the other's role. Our developer says, look, can you take the access away while we figure something out? The DBA says, well, what is that confidential data? Well, their customer ID number and their email address is enough for them to do a password reset option. So we can't have them floating around out in email land. The DBA says, well, rather than take away their access, what if we just mask it out of all their reports? Like you see on often websites, a credit card number will just have X's and just the last 4 digits, something like that. The developer says, well, we can't do that because they have their own reporting tool. We have no, this isn't part of the application. We have no control over the SQL they write. This is their own tools. The DBA says, well, the database can actually do that for us. The developer says, now that has got to be lies. That's got to be rubbish, surely. But it's not. In Oracle 12c, we have data redaction policies, the facility to redact data as it's queried from the database. And once again, it's something the DBA will be familiar with because it's an existing technology. We can use the dbms redact package to add policies. In this case, I'm taking the column name customer ID and doing what we call a full redaction, wiping it totally. And I'm also taking that same policy and applying what we call an email-based redaction to the email column. That's just a couple of examples. Now, when I run a select statement on our customers table, notice that the customer ID has been masked to 0 in all cases, and the email column has had partial redaction, and that was one of the options I chose in the previous slide. So I've left some of it there, but obviously the critical point, the bit before the @ sign, has been masked out. That applies to any SQL statement that's run that matches that policy, depending on which user connects and the like. Key thing here is redaction isn't about security. It's not about stopping access to data. It's really about protecting the data that has, let me start again. It's about protecting data which is legally allowed to be accessed from being distributed incorrectly. It's about securing the distribution of data. Redaction isn't about stopping someone being able to work out what the source data is if they had unlimited access to the database. It's not about that. It's about once you've got that data out, how can we protect it? Our developer says, that is amazing. So what about stuff if we expose some of our data via REST to external third parties? Is that going to be protected as well? The DBA says yes. We can control which users, which accounts, and which means by which people come to the database, what policies are applied. Well, by collaborating, instead of months of development, we've cranked this out in just a few weeks. And we now have a developer convinced on the benefits of the database. There's so much cool stuff in the database. And we have a DBA who's now convinced of the benefits of fluid database design. Thanks for including me in discussions. I know more about your app now, and we can keep evolving it and improving it into the future. And here, of course, is a lovely cliche, which I'd imagine very few developers and DBAs have encountered in their lifetime. Let us have a very happy end of this story and a celebratory drink together and become the best of friends. Now, perhaps I'm making too much of a jump there in terms of where we might actually end up. But you can see what we're trying to achieve here. We're trying to achieve the fact that collaboration between developers and DBAs, understanding the technologies both in the database tier and the non-database tier, is going to give you better results, right? And understanding the technologies, from my perspective, particularly in the database. And here's the key thing, a way of summing up today's webinar. People often say that, it's a relational database. So it's uncool, it's unfashionable, it's not one of the hip things out there. It's a legacy product. It's covered in cobwebs, shall we say here. But the reality is, and maybe this is perhaps too big a stretch, it could actually be a nice peacemaker in your organization, a way of bringing your DBAs and developers together. You've got that increased flexibility with Oracle 12c, having native JSON support, but also REST services to expose that data simply out to your developer community. You've got that lovely scalability that's always been in the Oracle database. You can either scale up with bigger servers, with more cores, or scale out with rack. It all just works as it always has with the Oracle database. You've got the in-memory column store. which lets you do real-time analytics, even if that source data is JSON documents as opposed to a relational database. And most importantly, because it is the Oracle database, all the normal security facilities are there, plus the ability to encrypt the data, which we didn't show today, and also to redact the data as it's exposed out from the database. So that's pretty much it for me, right? I'm pretty much done. Hopefully you took a little bit of the humor in there with a bit of tongue in cheek. And if you're a developer watching, then hopefully you're not upset about the DBA comments. And if you're a DBA watching, hopefully you're not upset about the developer comments. But hopefully you can see that collaboration, and that's what my big focus is on today's talk, is collaboration between developers and DBAs and an understanding of the technologies that are available natively in the database, in particular in Oracle Database 12, is hopefully going to give you faster development time, quicker time to deliver, but also preserve all those important aspects of security and data longevity and backup that DBAs are interested in. So thanks very much for your time. I'm finishing 3 minutes early, which is good because it's a Friday afternoon for most of us. So please have a beer on me, and please reach out to me on asktom@oracle.com if you have any questions. And also, don't forget, I'll just go back to a couple of slides. Please jump out and reach out to me on Twitter at Connor_MC_D, or get in touch with me via my blog, connor-mcdonald.com. Hopefully you enjoyed the webinar, and please keep watching the rest of the webinar series that's been put on by Francisco. It's a marvelous effort by him. And yeah, have a great weekend, everyone. Thank you very much for your time.